inability to see air with the naked eye is a consequence of the molecular composition of air and the physics of light. To understand this phenomenon, we need to explore the nature of air, the interaction of light with matter, and the limitations of human vision. 1. Molecular composition of air. Air is primarily composed of nitrogen, about 78%, oxygen, about 21%, and trace amounts of other gases, including carbon dioxide, argon, and water vapor. The molecules in air, such as nitrogen, N2, and oxygen, O2, have a specific property that contributes to the invisibility of air. They do not strongly interact with visible light. 2. Interaction of light with matter. When light encounters a material, it can be absorbed, reflected, or transmitted through the substance. The interaction depends on the properties of both light and the material. In the case of air, the molecules within it have minimal interaction with visible light, particularly in the wavelengths that our eyes are sensitive to. 3. Transparency of air. The transparency of a material refers to its ability to transmit light without significant absorption or scattering. Air is transparent to visible light because the molecules in the air allow light to pass through almost unaltered. Since the molecules in air don't absorb or reflect light strongly within the visible spectrum, the light essentially travels through the air without being significantly affected. 4. Human vision and the invisible nature of air. Human vision relies on the interaction of light with the photoreceptor cells in the retina of the eye. These cells, called rods and cones, convert light signals into electrical signals that are transmitted to the brain, where visual perception occurs. However, regardless of the type of photoreceptor, the key is that these cells can only respond to the light that interacts with them. Since air is transparent to visible light, light passes through it without causing significant interactions with the molecules. As a result, the photoreceptor cells in our eyes do not receive the cues needed to generate a visual signal. Therefore, we perceive the space occupied by air as empty and transparent. 5. Indirect observations of air. While air itself may be invisible, there are situations where we can observe its effects indirectly. One notable phenomenon is the refraction of light. Refraction occurs when light travels through a medium with a different optical density, causing a change in the direction of the light. Changes in temperature and density in the atmosphere can lead to variations in the optical density of air. This phenomenon is often visible on hot days when the air near the ground is warmer than the air above, causing light to bend and creating mirages. In these cases, while we are not seeing the air itself, we are witnessing the impact of air on the path of light. 6. Visible effects of air. Although air is typically invisible, its presence becomes apparent when it interacts with other substances or when impurities are present. For example, particles in the air. When there are particles or impurities in the air, such as dust, pollen, or water droplets, they can scatter light. This scattering becomes visible, especially when sunlight illuminates the air. The classic example is the visible beams of sunlight streaming through a room, highlighting the particles present in the air. Fog and mist. The visibility of air can be enhanced by the presence of water droplets. Fog and mist are essentially suspensions of water droplets in the air. When light encounters these tiny water droplets, it scatters, making the fog or mist visible. Again, it's not the air itself that we see, but the scattering of light by the water droplets suspended in it. Smoke and vapor. Introducing smoke, vapor, or other visible substances into the air can provide a visual representation of air currents and movements. While the smoke or vapor is visible, what we're observing is the material carried by the air, not the air itself. 7. Visualization techniques. In scientific and artistic contexts, various visualization techniques are employed to represent air and its movements. Smoke trails, wind tunnels, and computer simulations are examples of methods used to visualize the behavior and flow patterns of air. While these techniques provide insights into the dynamics of air, they involve the visualization of added elements such as smoke, rather than the direct observation of the air itself. 8. Conclusion. The invisibility of air to the human eye is a consequence of its molecular composition and its minimal interaction with visible light. While we cannot see air directly, we can appreciate its transparency, allowing us to navigate and perceive the world around us. The invisible nature of air highlights the intricate relationship between light, matter, and human perception, showcasing the complexity and beauty of the natural world.